Welcome to Unit Circle Survival Guide. Today we'll be looking at how to calculate exact values using a method I like to call SARC. And that just helps you remember the order of steps so that you end up with an accurate exact value. And this method will be for our special angles on the unit circle. So here's the method. It's SARC, S.A.R.C, and this will help you find exact values in 4 quick steps. So here they are. Step 1, we'll sketch our angle, specifically the terminal side. Step 2, we'll think A.S.T.C, and that's our acronym to decide which trig functions are positive in each quadrant. So that'll help us determine if we should have a positive or negative sign for our answer. Step 3, R, we'll find our reference triangle, which will help us get the coordinates that we'll need in order to calculate our exact value. And then step 4 will be to actually perform the calculation. That's the C. And so you can tell here is SARC spelled out, S-A-R-C. And this will just help you make sure that you remember each step and get that accurate exact value. So let's break it down just a little bit more. So step 1, we'll sketch our angle. And really we want to sketch the terminal side of the angle because that's how we'll get our coordinates. So for example, let's say we were trying to sketch the terminal side of 120 degrees. Okay, we know 90 is here, 180 is here, and so 120 must be 30 degrees past 90. So we sketch our terminal side and we see that that is in quadrant 2. And knowing that will be essential to our next step where we will decide if the answer should be positive or negative. Now do note you may need to find a coterminal angle. So if you have a rotation that is greater than 360 or greater than 2 pi, you'll simply have to find its coterminal angle so you can sketch the terminal side. So for example, if we were working with the angle 480 degrees, you would simply need to find the coterminal angle. So subtract a full rotation or 360 degrees. And that would get us 120, and so we'd have the same sketch as above. If you were working with a negative angle, you'd simply need to add 360 until you got one that fell with its terminal side on your sketch, on your unit circle. And if you were in radians, simply add or subtract 2 pi. And I'll post some links with videos that have a quick review of that, but with a little bit more detail. So look for those in the video description. All right, so step 2, that A tells us to think A.S.T.C, which is our acronym for determining which trig functions are positive in our quadrants. And knowing this will allow us to choose, is our exact value going to be positive or negative? All right, so remember A.S.T.C, you can think of it as all students take classes. And this tells you which trig functions are positive in the corresponding quadrants. So all are positive in the first quadrant, sine and its reciprocal cosecant in the second, tangent and its reciprocal cotangent in the third, and cosine and its reciprocal secant in the fourth. So for our angle that we used as an example in the previous step, it fell in the second quadrant. So if we were finding the sine of 120 or the cosecant of 120, those would be positive. Otherwise, our final answer would be negative for any of the other trig function exact values. So the big thing here, after you've determined that, make sure you mark in your final answer either a positive or a negative. All right, step 3 is to determine the reference triangle, that's the special right triangle, that you'll use to find the coordinates. So we will determine our reference angle, and remember that's just how much rotation to get back to the x-axis. So for example, we used 120 degrees earlier, and so we would know that our reference angle, or the amount of rotation needed to get back to the x-axis, would be 60 degrees. Once you have that reference angle determined, you'll find the corresponding special right triangle, so you can get the coordinates that are for that angle on the unit circle. So here's a quick first quadrant, and this is just so we can draw in our special right triangle. We would draw in the triangle that has a 60-degree angle as its central angle. Here's our right triangle. So you see that's 60, and we don't have to worry about the sign here. Sometimes when calculating exact values, there are so many ways that you can do that, but it gets really messy with signs, and that's why we already decided on the sign in the previous step, and all we need are just the simple values as positive coordinates or the first quadrant values. And so we know here in the 60, 30, 90-degree triangle, we know that our horizontal leg is shorter, so that must be an x-coordinate of 1/2, and our vertical leg is the longer one, so that must be √3/2, because remember that's about 0.87 as a decimal compared to 1/2 or 0.5. So these will be the coordinates that we can use to make calculations in this particular example. And again, note that we already determined the final sign of our exact value in step 2, and that's why we can use our first quadrant positive x and y here. So in step 4, we'll calculate the value. So to do that, you need to recall your trig ratios. You should have these committed to memory. I will post a video for that I'll post a link in the video description in case you need a refresher on that. So this is your guide to tell you how to use those coordinates that you found in the previous step. And then you'll calculate the value and simplify it as needed. So let's finish out the example we've been using throughout this video. Pretend we wanted to find the sine of 120 degrees. That's the angle we'd been working with. So running through all the steps as a reminder, we found in step 1 that the terminal side of 120 falls in the second quadrant. So that's the S, sketch your angle. Step 2, we would use A.S.T.C, the acronym All Students Take Classes, to determine which trig function would be positive in the second quadrant. And so that's the S. So sine, and if we were calculating cosecant, are both positive in the second quadrant. Okay, so I like to go ahead and mark a plus, even though we don't need it. I like to just put it to remind myself I have considered that. Okay, so that's step 2. In step 3, we sketched our reference triangle, that's 60, 30, 90 triangle. And we found that our coordinates, our xy that we should be dealing with, will be 1/2, horizontal short leg, vertical long leg. And looking at the trig ratios above, step 4, we can calculate our value. So the sine of 120, the sine is simply the y coordinate when using the unit circle values. So we have the sine of 120 is positive √3/2. All right, so let's take a quick look at the template you can use. So remember SARC, S.A.R.C, and that'll help you remember which step comes next. All right, so step 1, we sketch our angle, specifically the terminal side, and so you can sketch in just a quick little grid here. Step 2, you'll think A.S.T.C, and that's where you decide is your final answer positive or negative. Step 3, you'll create your reference triangle to get the coordinates x, y, so that you can calculate in step 4, and just make sure you know those trig ratios. All right, so that's all there is to it. Hopefully this helps you become a pro at quickly and accurately calculating your exact values. Be sure to use this template. It will help keep all the pieces in place. And be sure to check out some of the videos with examples and how to use this to calculate exact values. Thanks so much for watching.